At 9:17 local time, this Australian P-8 Poseidon was cruising at 6,400 meters south of the Paracel Islands, running its standard reconnaissance pattern. After 2 hours of routine flying, Beijing scrambled their most advanced fighter to send a message. Little did the Chinese Su-35 pilot know that this was exactly what Australia wanted. 10 seconds later, the Su-35 exploded from the clouds ahead, twin engines in full afterburner, closing at nearly the speed of sound. The fighter crossed their nose at 180 meters. It was so close the Australians could see the pilot's helmet pivot toward them. At their combined closure rate of 1,600 km per hour, the margin between intercept and collision had been less than half a second. The wake turbulence slammed into the Poseidon like an invisible fist. The 86,000 kilogram patrol plane rolled hard left, autopilot disconnecting as the stick shaker activated. The pilots wrestled the aircraft level while their engines coughed through the disrupted airflow. The P-8's electronic support measures panel then lit up. An X-band fire control radar was painting them with focused energy. The IRBIS-E, Russia's most powerful fighter radar, was now drilling into their aircraft. Unlike search radars that sweep wide areas, fire control radar locks onto one specific target with a concentrated beam. It's the difference between scanning a crowd with a flashlight versus pointing a laser at someone's forehead. The Chinese pilots thought this was intimidation. The Australians thought this was Christmas morning. Welcome to Border Watch Daily, where we analyze critical events shaping global security. You see, those bumps and bulges along the P-8's fuselage aren't decorative. That's the AN/ALQ240 electronic support measure suite. Think of it as a digital vacuum cleaner that sucks up every electronic emission within 300 meters. The second that the IRBIS-E radar touched them, the system started cataloging frequencies, pulse patterns, scan modes, and power outputs. Data that China and Russia have spent decades trying to protect was now streaming directly to Australian intelligence via an encrypted satellite link. The Australian pilot re-engaged the autopilot, held 6,400 meters, maintained a heading of 095, and keyed the radio with a kind of calm that only comes from knowing you're already winning. This is an Australian military aircraft conducting lawful operations in international airspace. The Su-35 was already turning back for another pass. The Chinese pilot probably thought he was delivering a message. Oh, he was just not the one Beijing intended. The fighter materialized on their left wing like it owned the airspace. No dramatic approach this time. The Su-35 eased into position 40 meters away, matching their speed at 815 kilometers per hour. The Chinese pilot was attempting what professionals call close formation shadowing. What he was actually doing was giving Australia a private airshow. The P-8's MX-20 HD electro-optical turret, a high-definition camera system that can read license plates from 7,600 meters, was now recording at maximum resolution. Every weapons pylon, every panel line, every maintenance access point, the infrared channel was mapping heat signatures across the entire airframe. Engine exhaust at 1,200 degrees Celsius, avionics base at 82 degrees Celsius, even the warm spots where hydraulic lines ran beneath the skin. This data would tell Australian engineers exactly where future missiles should aim. The Su-35 was demonstrating its thrust vectoring capability. Those exhaust nozzles can pivot 20 degrees in any direction, making micro adjustments every few seconds. This technology lets the fighter generate control forces independent of airspeed. It can essentially hover information while conventional aircraft wallow through turbulence. Impressive engineering and now completely documented. The Australian sensor operators logged every nozzle movement, deflection angle, response time, and correction pattern. In a future engagement, Australian electronic warfare systems would know exactly how this aircraft stabilizes itself and exactly how to disrupt that process. From 40 meters away, the threat was obvious to everyone on board. If the P-8 made any sudden movement, their 37 5-meter wingspan would sweep into the fighter. The Su-35 could dance away in milliseconds with 28,000 kilograms of combined thrust. The Poseidon, with its airliner reflexes, would need several seconds just to begin a turn, but the Chinese pilot had made a critical error in judgment. He positioned himself precisely where the MX-20HD could photograph his entire weapons load in perfect detail, 2 R-77 radar-guided missiles on the inboard pylons, Russia's most advanced air-to-air weapon, and 2 R-73 heat seekers on the wingtips. The exact configuration was now documented and transmitted to fleet intelligence. The Su-35's wings rocked left and right, the international signal for "follow me." When the P-8 maintained heading, the fighter's vertical stabilizers reflected sharply, sending jet wash across the patrol plane's nose. A petty escalation that accomplished nothing except logging his flight control response times into Australian databases. "Maintain course," the pilot said calmly. "He wants us to react. Let him perform." The Chinese pilot was operating under a fundamental misunderstanding. He thought proximity meant dominance and that aggressive flying meant winning. What he didn't grasp was that every second information was another second of intelligence collection. The P-8 had already transmitted more data about Su-35 flight characteristics than Australian analysts had gathered in years. The fighter suddenly pitched up and climbed 150 meters above them, then rolled inverted. Whatever came next, the cameras would be watching. The Su-35 hung upside down directly above them for 2 full seconds. The Chinese pilot was looking straight down through his canopy at the Australians, his aircraft's entire 19,000 kilogram mass suspended by thrust vectoring and computer control. Fuel, hydraulic fluid, and weapons all fighting gravity, while those magic nozzles worked overtime to maintain inverted flight. It was genuinely impressive flying. It was also genuinely stupid. The maneuver should have been impossible at 815 km per hour. Too slow for normal aerodynamic controls, too fast for helicopter-style techniques, but thrust vectoring creates control forces that have nothing to do with airspeed. The Su-35 was essentially flying by brute force and mathematics. Its flight computer solving physics equations 100 times per second to keep from tumbling out of control. Australian analysts had theorized about these capabilities for years. Now they had high-definition video proof. The fighter carved a perfect barrel roll around the P-8's fuselage, tracing a cylinder in the sky with a patrol plane at its center. As it passed over their tail, the gap narrowed to 20 meters. It was close enough that tail cameras captured individual rivet lines on the Su-35's belly. One miscalculation and 21,000 kilograms of fighter would have sheared through the Poseidon's tail. The MX-20HD recorded the entire maneuver from multiple angles, rate of roll, altitude deviation, speed loss during the inverted portion, and recovery dynamics. The Chinese pilot had just provided a complete performance demonstration that would have required years of spy satellites and defector interviews to obtain. Otherwise, Beijing charges billions for this aircraft. Australia just got the operating manual for free. As the Su-35 completed its orbit and rolled level of their right side, its wake hit the P-8 like a punch to the gut. The patrol plane bucked wildly, nose pitching up 8 degrees as rolling vortices from the fighter's passage hammered their control surfaces. Autopilot disconnected. Airspeed fluctuated 74 km per hour in 2 seconds. In the cargo bay, sensor operators grabbed their stations as equipment crashed to the deck. They lost 550 meters in the recovery. Number 2, engine experienced a brief compressor stall. The FADEC system detected the disruption and restored normal combustion automatically. The auxiliary power unit triggered a restart. It was sudden but manageable. The Chinese pilot probably felt satisfied watching them struggle. He didn't realize the P-8 satellite data link had been transmitting continuously throughout the encounter. Every frame of footage, electronic emission, and performance data point. The intelligence was already at fleet headquarters before the Australians finished their recovery. Even if the P-8 had gone down, which it wasn't going to, the data was already safe. The Su-35 disappeared beneath them during the recovery. The tactical coordinator found it on his scope, climbing back towards them from below, but instead of taking position off their wing, it accelerated ahead. The fighter was setting up for something else. The Su-35 climbed through an altitude 300 meters ahead and yanked its throttles to idle. The fighter's speed collapsed from 815 to 460 kilometers per hour in 4 seconds. For the P-8 crew, it was like watching a sports car slam its brakes on a highway while they drove a semi-trailer. The closure rate jumped to 350 kilometers per hour. At that speed, they had 12 seconds before impact. The P-8's throttles came back hard, but turbofan engines don't work like fighter motors. The CFM56 took 3 full seconds to spool down from cruise power. 4,500 kilogram rotating masses of titanium following their own lazy physics. Meanwhile, they were eating up the distance at 97 meters per second. The collision warning system filled the cockpit with synthetic callouts. Traffic, traffic, traffic. The Chinese pilot had calculated what he thought was the perfect trap. Climb, and they'd stall in thin air. Dive, and they'd accelerate into him. Turn, and their wingspan would sweep through his position. The only option was to reduce power and hope the distance opened. 8 seconds to impact. The fighter grew larger in their windscreen. 5 seconds. The gap stabilized at 1,500 meters, but they were still overtaking. The stick shaker activated intermittently. Their margin above stall had compressed to 55 kilometers per hour. Here's what the Chinese pilot didn't factor into his calculation. His entire deceleration profile was being recorded. Engine spool down time, minimum controllable airspeed, throttle response curves, the exact numbers that would tell Australian tacticians how to force an Su-35 into an energy trap during actual combat. He was providing defeat instructions while thinking he held all the leverage. Just as collision seemed inevitable, the Su-35's engines erupted back to military power. The fighter accelerated and dove simultaneously, passing beneath them with 40 meters to spare. More performance data logged, acceleration rates, power on dive angles, recovery characteristics. The jet wash hit immediately. Invisible rivers of 760 degrees Celsius exhaust that made their engines surge and stumble. Number 1. Engine flamed out completely, a fire warning light illuminating as the FADEC fought to restore combustion. They were on a single engine at an altitude where every kilometer per hour meant survival. The crew initiated the relight procedure while fighting to maintain altitude. The situation was serious but not critical. These pilots had trained for exactly this scenario. The tactical coordinator found the Su-35 on scope again, climbing back up directly in front, barely 100 meters ahead. This time, something new appeared on the sensor displays. The fighter's countermeasure dispensers were armed and glowing. The UV-26 flare system, Russia's primary aircraft self-defense suite, was spinning up for deployment. It was not pointed away from a threat, but positioned directly ahead of the P-8's flight path. The Australian sensor operators didn't flinch. They adjusted their recording parameters to capture infrared signatures. The ALQ-240 suite prepared to capture electromagnetic signatures from the flare ignition systems. The Su-35 rose into position 80 meters ahead, 9 meters below their flight path. Engines aligned perfectly with the P-8's intake fans. At this distance, the Australians could see everything. Rectangular flare dispensers under the fuselage, chaff pods on the wing pylons, even the pilot reaching for his countermeasure panel. The geometry was deliberate. The fighter had positioned itself precisely where its flares would funnel directly into the P-8's engines, burning magnesium entering turbofan intakes. The best case was FOD, foreign object damage requiring months of repairs. The worst case was dual engine failure at 6,400 meters over open water. But the Chinese pilot had just made his biggest mistake of the day. He was about to demonstrate his countermeasure system. The UV-26 decoy dispenser is Russia's standard aircraft defense system, with 48 flares designed to seduce heat-seeking missiles away from the aircraft. Every military operates some version of this technology, and every military closely guards the specific characteristics of their flares. Burn temperature, spectral signature, dispersion pattern, magnesium composition. This data determines whether enemy missiles can be programmed to ignore the decoys and track the real target. The Chinese pilot was about to hand over that data for free. The P-8's infrared sensors recalculated automatically, optimizing for the expected thermal bloom. Recording parameters shifted to high-speed capture, thousands of frames per second to analyze the exact burn characteristics. all crew braced for impact, the pilot announced on intercom, "Prepare for possible engine failure." The sensor operators didn't power down their equipment. They just adjusted it. This was the most valuable 30 seconds of the entire encounter, and they weren't going to miss a frame. The Chinese pilot made one final radio transmission, threatening them to turn around. The P-8 maintained heading. This was the moment the entire encounter had been building toward. Every aggressive maneuver, every dangerous pass, every near miss, all of it was prologue to this. Beijing's pilot thought he was about to damage an Australian aircraft and force a retreat. What he was actually about to do was compromise his entire countermeasure system. Future Australian missiles would be programmed to recognize these exact flare signatures and ignore them. Every Su-35 flying these decoys would be more vulnerable because of what happened in the next 10 seconds. The P-8 crew understood the stakes on both sides. Yes, their engines might fail, but the data they were about to collect was worth more than the aircraft. Then the Su-35's belly erupted. 48 flares cascaded from the Su-35 inches, a blinding barrage. Each one was a 1980 degrees Celsius ball of burning magnesium spreading into a wall 18 meters wide and 30 meters tall, and the P-8 would hit it in 2 seconds. The Australian sensors captured everything: burn temperature, spectral signature across infrared bands, dispersion pattern, and timing intervals, all logged. In 10 seconds, the Chinese pilot gave away information that Russian defense contractors had spent decades protecting. Then the debris hit. The cockpit went white as optical sensors overloaded. Burning particles peppered the nose and radome. The pitot tubes registered chaotic readings as superheated air disrupted their measurements. The smell of hot metal seeped through the environmental system. The number 2 engine ingested the first fragments and the compressor stalled immediately. Airflow through its 38 titanium fan blades shattered into chaos. The FADEC cut fuel to prevent explosion and initiated a restart. But more magnesium fragments kept disrupting each attempt. Number 1 engine, already damaged from earlier, couldn't handle the additional stress. Vibration increased exponentially as molten magnesium warped the precision fan blades. The P-8 shuddered forcefully. Airspeed dropped 480 kilometers per hour. The stick shaker rattled continuously at this altitude. With both engines compromised, they had seconds before the wings stopped generating lift. The pilot pushed the nose down, trading altitude for airspeed. The tactical coordinator maintained his professional calm. Mayday, mayday, mayday. Australian patrol aircraft experiencing dual engine failure after hostile action. But even as he transmitted, he was also confirming data integrity. The satellite uplink showed green every frame of the flare deployment, every sensor reading, every performance parameter, all of it had already transmitted to fleet headquarters. The mission was complete. The number 2 engine roared back at 70% power, computers finally achieving stable combustion. Number 1, engine continued vibrating dangerously but maintained 40% thrust, enough to fly. The Su-35 peeled away and disappeared. Its pilot probably reporting a successful intimidation mission. He had forced an allied aircraft to declare an emergency. He had demonstrated Chinese resolve. Beijing would consider this a victory. They would be wrong. The P-8 limped toward Darwin on wounded engines, sensors offline, crew shaken but professional. They landed safely 4 hours later. The aircraft would need 6 weeks of repairs, but within 24 hours, the intelligence had already propagated across the Five Eyes network. Su-35 radar frequencies catalogued, thrust vectoring performance envelope mapped, countermeasure signatures analyzed for missile programming, pilot behavior patterns documented for tactical planning. Beijing sent a fighter to deliver a message. The message Australia received was, "Here's everything you wanted to know about our most advanced aircraft. An expensive mistake. Bye for now."